Hello everyone. Let us solve problem C of Codeforces round 689. In this problem, we are given an array of size n in which we have all the elements from 1 till n. And apart from the array, we are given sequence of operation. So for explanation, I will take this as an example. We have array of size 7 and these are the elements order, and we have these operations, sequence of operations. So each operation we have two values. The first one will tell how many elements to pick from the beginning, and the second one is the probability that we will sort it. And what will be the probability to not sort or not do anything is 0.4. And our goal is to find out what is the probability that after performing all these operations, the array will become sorted. So if you notice in this array that 5, 6 and 7 are already at their correct location, right? But not these elements. So if you perform the operation over here, for example, at this position from starting till this 5, the whole array will become sorted. Similarly, if you perform operation over here or here, the array will become sorted. Same goes for this position, the one before the sorted part, sorted segment. Right? But if you perform the operation anywhere else apart from those location, it will be of no use at all. It is of no use because, for example, you are performing operation over here, so it will become 1, 4. So the whole array is not sorted. So in order to make the whole array sorted, you will have to perform the operation at these location, any of these location, either 1, 2 or all of them, right? Okay. Now our goal is to find out the probability that this array will become sorted after performing the sequence of operation, these sequence of operations. So this is same as 1 minus probability that the array will not be sorted, right? Okay. So now we have to find out what is the probability that this array will not be sorted after performing these operations. So it's very simple. You don't want the array to be sorted, right? So don't perform operation at any of these places. So if you avoid the operation at and all of these places, this array won't be sorted, correct? So if say the probability to sort or perform operation here at this location is, say it is p, then what is the probability that it won't do anything? It is 1 minus p, right? So for this one, say it is p1, so it will be 1 minus p1. Now you don't want to perform operation here as well at this location, right? So it will be 1 minus whatever the probability is, like this, and you can do the product and find the answer, right? Okay, let us take this example to understand it better. So these are the places in which operations are useful, and these are the places where it is not useful. So the first one, 5 comma 0.6, which is here, yeah, it can be useful, right? 3 comma 0.7, it is not useful, so we can forget about this. Then 4 comma 0.4, this one is useful, and the probability is 0.4, and for this one the probability was 0.6. And next one is 7 comma 0.8, so here also it can be useful to sort the overall array. And for last one is 2 comma 1.0, 2 is here, right? And this is not useful to us. So if probability to sort it is 0.4, so what is the probability that you won't sort it? 1 minus 0.4, right? Similarly for 0.6, it will become 0.4, and for 0.8 it will become 0.2, right? So if you multiply this 0.6, 0.4 and 0.2, you will get the probability, this probability that this array will not be sorted after performing all these operations. So what is the probability that it will become sorted? You have to do 1 minus probability that it won't be sorted, which will be equal to 259.952. Okay, so this will be the answer. So the idea is simple. We have to find out what is the probability that that the array will be sorted after performing these operations. So instead of finding the probability of it being sorted, we'll find out the probability that it won't be sorted, and then subtract this from 1 to get the answer. And when it won't be sorted, when you will not perform the operation in this area. So if you want to perform the operation in this area, it cannot be sorted, right? Okay, let us look at the code once. I will keep it here just for the reference. Yeah, and this is the code. So we have an array of size n, and then we have sequence of operation, right? So will store the array elements in this A and the operation in B. Here we are taking the input. Okay, so one scenario we are handling separately when the array will be sorted already. So if the array is already sorted, in that case, whatever you do with the operation, it doesn't matter. The array will be sorted eventually at the end, right? You cannot make the array unsorted. So the probability will be 1 if it is already sorted, right? So here we are checking for the index where it is not, the last index where it is not at its correct location, right? This is what we are checking here. But if all the elements are their correct location, in that case, this value won't be updated. It will remain -1. So we can check it as -1. If it is -1, it means the array is already sorted. So the probability will be 1, and we are done. We'll return here, right? Okay. If the array is not sorted, then the scenario will be like this, like this. So in our example, this mismatch, right? For this example, the mismatch will be pointing to this element 3, because this is the last index or the last element which is not at its correct position. Like 5, 6 and 7 are at their exact location, but this is not. So this is what mismatch is in the code. So what we want to do, so we will go through all the operation here. Okay, and if the operation is of interest, like if it is of interest, then we will find the probability of not being sorted that we have done here, right? And just do the multiplication. And how will you find out whether this operation is of interest or not? Using the mismatch, right? If your value is greater than equal to the mismatch, if your first value is greater than equal to the mismatch, it means it is of use to us. So here in the code, if you look, we are checking if it is greater than equal to the mismatch, then we are doing this 1 minus the probability that you will make it sorted, right? And then you are keep multiplying it as I mentioned here. So once we are done with this section, we will have the probability that the array will not be sorted. Fine. Then what is the probability that it will be sorted? We have to subtract from 1. So here we are subtracting from 1 to get the answer. And this part is just to print up to 15th decimal. Like after the decimal, we'll print 15 numbers. Okay. I hope you understand the problem as well as the approach. Yeah, so that's it for this video. Thank you for watching.